Hello everyone. This is a video lecture for college algebra, math 1414, section P.5. I think that this is called factoring. That's at least what I'll be doing here today. Factoring! So, whenever I say factoring, well no, I mean, it depends on what your background is, I guess. I'm pretty sure they start you off with a pretty interesting problem here. So I often do number one. I can't remember if this is your real number one on the homework or not, but regardless. So I got 7x to the fourth minus 21x cubed plus 35x squared. And they say, go, factor, muhahaha. So there's a lot going on here, right? But really, factoring is pretty simple here. I'm going to remind you about this stuff again. Chapter P, we're assuming that you've seen this before, but I'm not going to assume it all the way that I won't do it at all. I still want to teach it, just maybe a little bit more quicker than the years you've probably have seen it. I want to see what each term has in common. What do they all have in common here? Well, they all got an x somehow. In fact, not just x, they've got x squared. They got two x's. This guy's got four x's. This guy's got three x's. This one's got two x's. So at least they got x squared, or again, I'm trying to say like xx. I got two x's that they all at least have. Is there something else that they all probably have in common? I think maybe a 7. I got 7 in the 7 times 3 right there, and that's 7 times 5? Yeah, so they all have a 7 as well. I'm going to put a 7 out in the front as well. And so you could do it all at once like I did it here. I'm just explaining it to you. But you could also say, well, take out an x. Take out a 7. They still have an x. So take out another x. You can do it in pieces and it'll still be okay. If you've already taken the 7 out, like basically I'm just going to recopy these guys. I've already taken the 7 away. I've already taken 2 of the x's away, so therefore it's left with 2 x's left behind. Again, 2 and 2 would make 4 total. And so if I took a 7 away from here, it would leave a 3. Did I take that minus sign away? Nope. So I got a negative 3x. I had 3 x's. 2 of them got taken away. Leave 1 behind, I guess you can say. And then finally, whenever I take here the 7 away, I got a 5. I already took both of its x's away as well. And so there you go. You're literally done. That's it. That's all it is. So not a lot of math. It's just a kind of a remembering of the steps and what's expected, etc., etc. You could. I have a little note here in my notes. I have a note in my notes that you could redistribute this and FOIL it all out or whatever, and you would get back to the original problem. That's kind of a way to double check. I know those are nasty words. I'm sorry. We'll have to do it eventually. Double check. So it is a way to just verify. I'm going to say, though, since we're all working with my Math Lab homework, the way to double check it, in my opinion, is to just put this in and see if it works. If it does, it does. If it doesn't, well, try again. Just my thoughts there. Okay. So I got a P57. They have x times x plus 13. And then I got a minus 20 times x plus 13. And they say factor. I don't think they say anything else in particular. They might use other words, but I'm going to assume no because I don't have them. Factor. Well, what do they all have in common? And it's kind of a little weird thing here. Each of these terms, these are terms here, they're split up with little pluses and minuses. They both have this x plus 13 in parentheses. But it's the same thing. It's that common element that they both have. And so I'm going to factor that out to the front. X plus 13. They both had that. Now, just like last time, I don't just eliminate anything. I don't whatever. Remember how they fell down, right? They fall down. So then I'm going to fall down with the remainder, the leftovers. If I already took this huge thing away, well, what's left over is just x. If I already took this huge parentheses thing away, it's already gone. That thing's gone. It's gone. So then what? What's left over? Right there. Minus 20. That's your answer. I'm going to make it, a little bit more pretty. There we go. Cool. That was it. That's all they're looking for. So Not too bad there. Okay. The next one, P514. I got x squared plus 2x minus 3x minus 6. And they say specifically here, factor by grouping. Factor by grouping. So if you've heard of this before, cool. Skip ahead to, 9 minutes into the... No, I'm just joking. I have no clue where I'll be. Factor by grouping is a very particular thing. If you've seen it before, cool. If you haven't, well, here we go. They're saying to group these, and then I'm going to factor within that group. I'm only going to look at this little group here, just this guy, and I want to factor right here. Only. That's it. What do these two terms right here, what do they have in common? What do these two guys have in common? What do they have together? They got an x. Both have an x. They only got one x together, though. Leaving behind an x plus 2. So I took an x from both of them. I get an x squared. It's kind of like xx. So I took one of those x's. I took this x right there. What do you got left behind? You can see what I'm saying. Same idea there. Okay, there you go. Over here, kind of interesting here. What do they have in common? 3. Right? We all agree with that. But don't they have something else in common? If I extend that a little bit more. They both have a minus sign. They both have a minus sign. So I'm going to say not just a 3, but I'm going to say a negative 3 comes out. Okay? Now this is going to be a little interesting. I got x plus 2 as my leftovers. Whoa, 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 whoa. Where'd that plus sign come from? Well, I mean, think about it. I'm going to take the negative 3 out to the front here, right? I want to take a negative 3 out of this guy. So that's negative 3 times 2 or whatever, right? Because that makes a negative 6. Well, I'm taking the negative 3 out. Taking the negative out. So what do we have in its place? Like, what sign, S-I-G-N sign, is this 2 right here? It's actually a positive. There you go. Or you could just say I took the minus sign out. You got to put something default there. Okay. Just to double check, just in case, you never know if I'm actually right or not. I'm going to take this negative 3 and I'm going to distribute it back into this guy. Just this on the side right quick. I got negative 3x. I got a negative 6. Did I get the original? Yes. So we're good. If it doesn't make sense exactly sometimes, just for one thing, you could just trust me. Haha. Or not. Or you can, go back and double check it for yourself to make sure it works. You're going to see that I use, kind of like imaginary math sometimes. I'll just pull out some things and you're like, well, where did you get that from? I'm doing it because I'm used to it. And some of y'all are used to this. But I want to also train you and teach you how to do that as well. So I've got these two parentheses things that they both have, right? I can keep going. It says factor. I can keep going. So then these are the same thing. I can pull them out to the front as an x plus 2. And then this basically becomes, again, big parentheses. Just like last time, I got an x minus 3. They just fall down. The leftovers just fall down. And that's your answer right there. That's factor by grouping. Basically, you have these two groups in the very beginning. Let me use a different color here. I got these two separate groups. I factored those individually, and then I could just pull something out that's common between them. Not every single time you do factoring is it factor by grouping. It's nice when they tell you. Next one. So I've got 5x cubed minus 3x squared minus 25x plus 15. And that 15 does not look good. There you go. Maybe it says factor by grouping? I don't know. Factor by grouping. It is factor by grouping, by the way. I'm going to use these two and these two as my groups. So what do these guys have in common right there? They both got an x. In fact, they both got two x's. So I'm going to say x squared comes out to the front, x minus, or 5x minus 3 left over. Again, if you're like doubting me, you can always redistribute this to both of them. I got 5 and I got 3 x's. And then I got 3 and I got 2 x's. Right? Over here, they have 5 at least. They got a 5 in there. think that's about it. So this is where it gets interesting here, because I really, really want the parentheses right here. Go back for a second. Notice right here on this problem, I'm going to use a different color. Notice right here, these things just magically happen to be the same thing. Kind of interesting. These just magically happen to be the same thing. Math magic. I want that same style here. I want this to happen. And then I can, factor it to the front and blah, 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 just like I was doing a second ago. And this looks like it could happen, right? I mean, if I take a 5 away, I get a 5. If I take a 5 away, I get a 3. Yes, but notice I got a negative and a positive. Somehow here I got a positive and then a negative. What's going on here, maybe I'm taking too long on this, I don't know, is that I'm going to have to switch the signs somehow to make it work. I'm going to not just pull out a 5 out of these guys, I'm going to pull out a negative 5. Okay? I'm doing this because I know that I need to have these parentheses the same. I have to. I knew this would happen. So now I just have to say, well, how does it happen? And so to do it, I'd have to pull out a negative of both of these to change their signs. Double check me. Look, I'm going to distribute. I got negative 5 times the 5 makes a negative 25. That's what I got. Okay, distribute over here. 2 negatives are going to make that positive 15. So it checks out. Again, if it seems a little strange at first, like, why did you do that? That's a great question. I guess I've been doing it so long that I just kind of see that we need to do something like this. But I'm telling you, because you're not as experienced, let's say. Again, I'm not assuming anything here. You want these to be the same. That's your starting place. And so then, how do I manipulate it in order to get that to work? That's my ultimate goal. If you just did the 5, it wouldn't be the same. You would get something wonky. So, and there we go. We're learning together. I want to use the red. So I'm going to say, look, these are the same. Factor it out to the front. 5x minus the 3. And then left over, the leftovers, which we leave behind, is these guys. Again, I'm just going to make it look pretty. That is your answer. You're done. And there we go. Sometimes we could even factor further. In this particular case, we don't have to, but like x squared minus 5. In this case, you can't do anything. Sometimes you might be able to. So just watch out for extra steps that might occur. P5, 17. I got x squared plus 10x plus 21, and they just say factor. Okay, now hold on. Pause. Big timeout. I'm setting down my stylus here. So when I say the word factor, I don't always mean factor by grouping. I don't always mean like the common term, the greatest common, whatever, blah, blah, blah. I don't know all the words. But what I do often mean is this guy. And this is what you think too. When I say the word factor, this is what was drilled into you back in high school, or could have been yesterday for all who knows. But this is what you do a lot of, and that's what we're going to continue to do here in this class as well. What they're wanting to know, here's the question. I'm going to say, what 2 numbers are going to add to that 10 in the middle there and multiply to the 21 right there at the end? What 2 numbers are going to add to the 10 and also multiply to 21? That's my question. If you can find those 2 numbers, then you're basically done. You just put it in the format that they want. I wouldn't say start with the things that add up to 10. I mean, 1 and 9, 2 and 8, 3 and 7. You'll be there forever. And heck, we could even do negatives if you wanted to. 11 minus 1 is still a 10. I mean, when it says add, it could mean subtract because you're technically adding a negative. Could happen. It'd take forever. We want to focus here instead on the multiply by 21. Again, if you've done this kind of problem before and you already know the answer, I guess you could skip ahead. I don't know. But I'm trying not to assume anything. So here we go. I'm going to multiply all my numbers that multiply to 21. Here we go. Let's make a list. 1 times 21. I mean, doesn't that equal 21? We got 3 times 7, right? I think that's it. There's not really a lot here. Sometimes we get a big old list, especially if it's even. But this one's not too bad. I'm wanting to know, out of these sets, these pairs, what would maybe add up to a 10? Could I make a 1 and a 21 somehow a 10? No way. No way. I don't know why I just crossed through that. Question mark? No. But what if I had a 3 and a 7? Is there a way to make a 10? And you would say, yes. That's a smiley face. Yes. What if I said 3 plus 7? That would make a 10. Aha! You see the point here. I'm going to start with the things that you multiply to get up to that last number. And then you take from those pairs, you see which you can maybe add or maybe even subtract to make the middle number. So my goal here now is to somehow say plus 3 and plus 7, these are my answers. How do I now put those into my math lab? What do they want out of this? Well, remember that we're factoring here. And factoring, if you go back to all the other answers, parentheses with an X on the inside, right? Basically, what they're wanting you to do here, I'm going to rewrite this from the beginning now. What they're wanting you to do is say, okay, what two numbers are going to add up to the 10 but multiply to the 21? And we already found them right here. A plus 3 and a plus 7. Now, I know you're probably asking, hey, I did it 7 and 3. Yeah, that's correct. Both of these are correct. My math lab understands. They're both good. I mean, computers are not the best thing in the world, but I mean, at least they understand that those are the same thing. So either way. And that's it. So as I continue on, it says factor. I often write this below it, this kind of, I don't know, symbol thing, because it's something that we're kind of familiar with. And then all we need to do is fill in the numbers here that work. One last thing before I keep moving. I know that somewhere at some point they did some kind of box thing, and then you got your X's, and then you got your... I have no clue about the box thing, okay? So if you're a box thing kind of guy or girl, go ahead. I'm not a box guy, so I'm not going to do that, okay? So moving on. We got the next one, P523. I know that I've skipped a lot of questions on your homework, but this, of course, I'm not going to do them all, but this one right here, we cannot skip. We can't skip this one. I mean, I was showing you something so easy, right? Oh, yeah, two numbers, no problem. What makes this one hard? Can you tell? It's right there. That 5 right there makes me frown. It's really sad. It changes the whole dynamic of this problem, and it's not as easy as it used to be. We'll get back to the easier problems here in a second, but we have got to even do these tough ones. So how do I factor this one? My traditional answer is to do this. Somehow you're trying to figure out some numbers that are going to multiply to the 7 and, finger quote, add up to the 34. Not really. So, definitely a little different dynamic here. That's why it's a little bit more difficult. Just telling you, and this is kind of a guess here. We got a 7 here. The only numbers that could work here are a 1 and a 7, or a 7 and a 1. Those are the only things that work. And when I FOIL this, like, say if I were going to double check this thing, I have a 34 in the middle. If I had a 7 right there and a 1 right there, when I FOIL this thing, I got 5 times 1 is 5. I got 5 times the 7 is 35. Pretty darn close. And then I got a 1. So now I'm working with a 35 and a 1. Do you think I can make that 34 happen in the middle there? Probably. And then a 1 times 7 makes the 7. And so we're good. So this is good here. Notice that we have a minus sign here and here. I want a negative 34. I had a 35. So what if I have a negative 35? I'm going to add 1 to it. That's your answer. Blah, blah, blah. There's a lot of ways to do this problem. You can reason through it like what I did just now. But if you're confused, that's okay, because I'm not going to do that. I'm not going to do it with this problem. I'm going to do something else. I have a strategy, I guess like a formula kind of for that. But in the end, can you reason through this and get the right answer? Yes. Yes, and you can do it quickly. But let's go through the slower process because it's a little bit, I don't know, maybe it's easier. I would say it's easier. It's longer, but it's easier. Okay? Formulas are good. Everyone likes formulas. So here we go. I'm going to use a different color here if that's okay. 5 and the 7, negative, positive, doesn't really matter. I'm going to multiply those guys together, 5 times 7, and I get a 35, okay? There's no relation to 34 right now. Just, I got a 35. Cool. I want to find two numbers that would multiply to make 35. Now, I know it's kind of weird because I already have two of them right there. Well, are there other sets of numbers that multiply to make a 35? Well, 1 times 35, and I got 5 times 7. Same thing, right? Both of these will make a 35, so that's good. I'm going to take from these groups here, from this group here, I want two numbers that are somehow going to add up to the 34. Okay, yeah, negative, positive. We'll talk about that in a second. Will 5 and 7 somehow add to make a 34? No. But what about these guys? So I know that it's not 1 plus 35. That makes it 36. That's not correct. We want 34. So what about like 1 minus 35? Or, I guess, negative 1 plus 35. Either way, the idea is that these are the numbers that we're going to use for my answer. Now, more specifically, we have a negative 34, right? And so negative 34 is actually what I'm really wanting. So I have a positive 1 and a negative 35. Okay. Now, I'm going to take these guys here. This is all part of the formula, okay? Let me go back to the original if it's okay. Here we go. My original. 5x squared minus 34x minus 7. I want to rewrite this middle term here using these numbers. So I got 5x squared plus 1x minus 35x minus 7. Now let's just pause for a second. What I did, this is a formula. I'm just following the formula. I told you it's going to take a long time. I took this and I split it up. Is negative 34 the same as a positive 1 and a negative 35? Yes, we just checked that over here. And yeah, they both have an x. Sure, apples and apples. But why did I do that? Well, that's part of the formula. I think that if I look at this now as factor by grouping, this is a group, this is a group, there might be a way for me to somehow get an answer really quickly. Looking at this group right here, just this group right here, this is factor by grouping. Let me even write that here, factor by grouping. What do they have in common? X. Took one x away from both of those. Here, what do they have in common? They both have a minus sign, and they both have a 7. Leaving behind a 5x plus 1. Again, I took the minus sign from both of them. You better have something in there. Two negatives make a positive. Also, knowing ahead of time, this was the easier one, and I was expecting to have this guy here as well. I knew that I would have this 5x plus 1 here, otherwise this factor by grouping ain't going to work. I got to have it. So then I can take these, factor them to the front, leftovers, x minus 7. There you go. That's your answer. You're done. Let me scroll up and see if I got that originally. Boom. Same thing. Look at these steps here. I didn't even do any steps. Just kind of looked at it. Yes, there's a lot of steps here. But we did get to it. Either way, let me just recap on the long way, okay? I have my original, and I'm multiplying both the ends to get a number. And I'm saying, well, what two numbers can multiply to make that happen? You're, of course, going to get the same pair of numbers every time, but maybe there's others. In this case, 1 times 35 still makes it 35. I want to see if these numbers will somehow add or subtract up to the number in the middle, and these guys are my winners. So if I had a plus 1 and a minus 35, I get a negative 34. That's what I wanted. And I'm going to take that 34 here, use a blue here. I'm taking this guy, and I'm splitting it up. Right here. Okay? For what reason? I don't know. I'm splitting it up so that I can do factor by grouping. There you go. And I say, oh, what do they have in common? Factor it out. We're done. So at that point, we already know that stuff. That's happy times. You might be wondering, well, what if I had done a 5x squared minus 35x plus 1x minus 7? What if I did that instead? Could I still factor by grouping? Yep. You would get the exact same answer. It might be a different way of getting there, but it will still work. Okay? I don't know exactly how, but it will. Okay, cool. So this is good too. Either way is fine. Whew, that was a big problem. Any questions? Okay, moving on. So, one of the things about recorded lectures, I guess, is no direct questions as we go. So x squared minus 144. And they say factor the perfect square. They say that. It's nice that they say that. Factor this perfect square. There's very little math going on here. If you want to see it theoretically, we got a 0x in the middle. I'm asking you, here we go, I'm asking you, what two numbers are going to multiply up to 144 and yet add up to the 0? Now, like, what's just two numbers multiply to 144? And you're thinking, 12 times 12. What two numbers could add, again, or subtract, to make a 0? Well, what about 12 minus 12? You get the idea, the answers are 12s. But now there's a positive 12 and then a negative 12. So I got a negative, and then a positive. Again, you could do the positive and then the negative. Either way, your answers are 12s. You could very easily skip all the steps and all the reasoning by just seeing 144. What makes a 144? 12 and 12. Here, let's do some more. What if I had a 9? Got a negative 3 and a positive 3. I know, you just said that, didn't you? What if I had a, there's a minus sign there, sorry. What if I had a 25? Oh, it's 5 and 5. Right? That's easy. You get the idea here. Uh-oh. What about a 1? It's 1. 1 times 1 is 1. Get the point. Okay, cool. Keep cruising. P543. I got 25x. Whoa, I zoomed in there. Well, you know, no computer's perfect. 25x squared minus the 144y squared. And they say yet again, perfect squares. Perfect squares. Huh? Well, this is really no different than the last problem. I'm just going to ask you in a slightly different way. What two numbers make a 25? Come on, what do you think? 5 and 5. What two numbers do you think will make a 144? 12 and 12. Then just like the pattern for all the others, you got a negative, you got a positive. The reason why is because the inside is 0. When you add them up, you make a 0. That's why I got a negative and a positive. They'll cancel one another out. That's it. That's the entire answer. I don't really have another way of doing this problem. It's just seeing that it says perfect squares. What two numbers multiply to make a 25? Now notice that we have x squared right there. I'm splitting it up as x and x. You could, again, always double check me by foiling this thing out, which I guess we'll do eventually. Distribute and see what's going on. Next question. So, I've got a lot of questions in this section. That's good for you, not for me. Well, I like it, actually. It's pretty fun. 4x squared minus 4x plus 1. Hope you're having fun, too. It says factor the perfect square. And in my notes, I've got a little question mark next to it because I don't know what they're talking about. I don't know. They're wanting to factor it like we have been. Negative, positive. Somehow there's going to be the same numbers. That kind of thing, maybe. I don't know. Is that what they're wanting? Well, just like the last problem here, it was kind of weird, but I want to say what two numbers multiply to make a 25. So what two numbers multiply to make a 4? Well, it's 2 and 2. That's easy. Just like the last problem, what two numbers multiply to make a 144? What two numbers multiply to make a 1? Well, 1 and 1. This is where it gets a little bit different. Notice that the inside is not equal to 0. The middle part is not equal to 0. Every other time it says this perfect square, it's 0. Right here. 0. Look, what's on the inside there? 0. There's nothing there in the middle. No middle term. Here we got something. We got something. It's not 0 anymore. I don't know how that works, but you know what's interesting? I have a negative sign right here. And I got a positive right there. I'm saying somehow I'm going to have negative answers. Okay? I have to have negatives somewhere. But the very last term is a positive here. The only way to have a positive is that I have positive 1 times positive 1 equals a positive 1. Or I got a negative 1 times a negative 1 equals a positive 1. Two negatives make a positive. Well, because I have negative at all, I'm going to have to include negative somewhere. What if they're both negative? So I'm not following this strategy anymore. I'll show you why here in a second. This is basically your answer. In fact, what's going to happen now is that there are two of them. And so they're going to just say, oh, go ahead and write a square. Now, I think that my math lab's going to be okay without you putting a square there and just writing it out long ways. I can't really remember, though. I'd say try it out and see what happens. So, not a lot of explaining on this. Is there some other way to do this? Well, honestly, not really. But there is a way to double check to see if it makes sense. So you could always take what you have here and say, is that correct? And we're going to FOIL that out. And when I say FOIL, I'm meaning whatever FOIL means, first, outer, inner, last? I don't know. Can't really remember. Basically, it means distribute. And that's what we're going to do. So 2x times 2x is 4, not 2 there, 4x squared. 2x times the 1 is negative 2x. Negative 1 times the 2x is negative 2x. And then negative 1 times negative 1 is a positive 1. These guys right here, combine like terms. Did I get the original? Yeah, I did. So that works. This is good. That works, everything works. This is the answer. We're good here. So that's a way to do it, I guess. Just watch out for whenever it says perfect squares. Often they're trying to say they look the same. They look the same. That's what they're trying to get at, okay? P557. I got y cubed plus 512. And they say factor. At least I'm guessing this is still on your homework. Yeah, I was confused too. Perfect time to explain and talk about my math lab. So there are a couple questions that you're going to find that are just confusing. I mean, for one, I'm not going to do every single problem. Not that I can't. I'm just trying to say, you know, you got to do some. I'll do some with you here. But this problem here, I personally don't know what to do. And I'm your teacher. So that's a problem, isn't it? So what do we do in these cases? Surely you know what to do. Put a 0 in there and hit enter. It says you're wrong. Yeah. Keep the 0 in there. Hit enter again. Like submit. Submit your answer again. Oh, you're still wrong. Blah, blah, blah. It has a lot of words. And then you hit submit again. Third time. And it'll say you're wrong. But here's the answer. Can I give you the answer? There we go. That's their answer. And then you're thoroughly confused. How did I get that? And then whenever you say, okay, whatever, try again or whatever, a new randomization, then you would get the same problem, but with some other number here. I don't know, 128 or something like that. I have no clue. Here's the point. I'm not saying that you're gaming the system here. I'm just wondering, what are you asking for, my math lab? My math lab, you say factor. What do you mean by that? Give me what the result should look like. Does that make sense? Hopefully. So I'm not trying to cheat here. I'm just wanting to know, what are you looking for? You know, what are you trying to get out of me here? Obviously, that's complicated. If you were to read what comes up whenever you do hit submit with like a 0 or something like that, if you were to read that blah, blah, blah text box or whatever, this time it actually has something important. It gives you a formula. Yep. A cubed plus B cubed is equal to A plus B, and then times A squared minus AB plus B squared. They give you that within the words. I would not say every single time that the words are important. Often they're so unimportant that I just skip over them. But in this case, they're actually important because this formula is required to make this problem work. That's all this problem's going to be, is just the formula. Okay? I'm looking here and I'm saying, you know what? This looks something kind of like this. Notice I got a Y and I got an A. So Y equals A, or A equals Y. Somehow, though, I'm supposed to also see that this 512 is supposed to be B cubed. Well, what about this? What about 8? And the reason why is because 8 cubed is 512. How do you know that? You got a calculator, don't you? Try some numbers out. 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 8 cubed. You get the idea. These are going to be my numbers or expression letters, numbers, that I use in this formula. So I'm literally just going to copy this formula. Here we go. Not A, Y. Not B, 8. Not A, Y. Not A, Y. Not B, 8. Let me use parentheses. Not B, 8. Clean it up a little bit. Make it look pretty. Wow. We just got the same answer as they did. Look at that. Because we followed the formula. Am I supposed to know that formula? I'm supposed to memorize this for a test? I don't know at this point. I have not memorized it myself. There you go. That's what I'm going to say. I have not memorized it myself. Moving on. So, the next one, I got 5x to the 4th. It's a 4th power. Minus 405. And they say factor. This is confusing because that 5 in the front is not very friendly. Here's the thing, though. Try to find a way to make it easier before you go and do the hard stuff. What do they both have in common? They both got a 5 in common. Now, I do not know what 405 divided by 5 is, but good thing I got a calculator. And it's 81. That looks like a pretty interesting number there. What two numbers multiply to make an 81? I don't know. What do you think? 9 times 9? Now, hold on. I did something wrong here. I didn't actually do the right thing here. This was a 4th power. That was a 4th power. What I'm actually needing to do is put a square here and here. Okay? How do you make a 4? Well, it's 2 and 2 make a 4. Again, I kept that 5 in the front there. Okay, cool. Remember that we had a 0 in the middle, right? There's no term here in the middle. I guess you can actually erase this thing and say that's a negative 81 and put a 0x in the middle there. That's kind of my point. I'm saying that there's nothing here in the middle. What do we do? A negative and a positive will cancel. Negative 9 plus 9 cancel makes a 0, etc. We did that earlier. If I type this into my math lab, they're going to say, well, although your answer is correct, you blah, 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 simplify, blah, blah, blah. Okay, yeah. So what they're saying is that we're doing it right, but we got to keep going. And in fact, right here, if you notice this little section, you can still factor that. What two numbers multiply to make a 9? 3 and 3. Negative and a positive, just like we just did a second ago. Now, here's the thing. This one here you cannot factor. I know you're thinking, oh, well, 9 makes a 3 and 3. It's got a plus sign. It's got a plus sign right there. So you can't actually do it. That's kind of one of those rules that you kind of learn as you keep going. When you got a plus sign in the middle, you can't factor it. You just leave it alone. You can technically factor it. I know some of y'all are smart enough to see that it's imaginary numbers, blah, blah, blah. That's not the point here. We're in Chapter B. We'll get to imaginaries later. Okay. And yes, we will. We will get to imaginaries later. P5117. They're not hard. We'll go through them and they'll be easy. This is a word problem, and the numbers will change for you, of course. They got, I think it's like a cardboard box, and they're cutting out corners to make a box, basically. We've got 3 and 3 for each one of these little sides here. And then they say that we have 5x and 5x. 3 and 3, 5x, 5x. And they want to know what's the area of the shaded region. Area of the shaded region. So it's a word problem, kinda, but not really. So looking at this big old original cardboard square. It is a square. What would be the big area? Well, it would be 5x times 5x, length times width, right? But then remember that we're going to cut out the corners. So I'm going to say like the big area minus the 4 corners. That's kind of like my English formula. So minus 4 times. Well, how much area is in a corner? Like what right here? How much area do we got there? Well, 3 times 3. It's going to make a 9 here in a second. That's your answer, basically. I just need to simplify a little bit. These are supposed to be equal signs, but whatever. So right here I got 25x squared, and then 4 times the 9. Here, 4 times the 9 is 36. And that is what they want for answer for part A. There's a part B! At least I think so. I have it in 2 parts on my paper. After this, they want part B to factor it. This is that perfect square kind of stuff again. I don't think they actually say it, but it is what's going on. Notice that we have a 0 in the middle. And so whatever I do, I'm going to, get rid of the middle terms, basically. I'm going to have a plus and a minus. So what 2 numbers multiply to make a 25? 5 and 5. What 2 numbers multiply to make a 36? 6 and 6. And notice again that I have a 0 in the middle, so I'm going to have a minus and a plus, because what happens is, again, they cancel. Let me show you that. I say it a lot, but let me show you that. 5 times 5 is 25x squared. 5 times the 6 is a positive 30x. Negative 6 times 5 is a negative 30x. And then negative 6 and positive 6 makes it a negative 36. These guys cancel. See what I'm saying? Leaving you behind with whatever you had originally. So this is your answer. That's your answer. That's what they want for part B. One last question. This is a big section. Glad we covered it, though. They have this rectangular something box thing. And it has a hole in the middle, and that hole runs the length of it. Something kind of like that. And they say that the sides of this original box are A and A. And for the little inside cutout, it's B and B. They say, oh, and the length is 10A. So there you go. They say find the volume. Find the volume. So volume is length times width times height. So I'm going to say A times the A times the 10A, right? That's the big, the full volume. But I removed this little guy here. B times 10A. Now that's kind of weird here. Again, length times width times height kind of thing. So I got my length, my width, and my height. So they share the same 10A, both of them. That's okay. They want you to simplify this. So notice how many A's we got here? We got 3 of them. And here we actually have an A and 2 B's. And that's your part A. Funny how that works. Part 1. And now they say for part B, part 2, we're going to factor it. What do they all have in common? Well, they definitely have a 10. They definitely have an A, leaving behind A squared minus B squared. That looks familiar. I know that it doesn't have numbers, but it's the same concept. I just simply rewrite it, not X, but A. What 2 numbers multiply to make a B squared? B times B. Because there's a 0 in the middle, there's nothing in the middle there. A negative and a positive. So let me clean that up a little bit. And that is your answer for part B, part 2. And that's it. Okay, that's all I got. Whew, that was a big section. Thank you very much, guys. Have a great day.